According to CDC, the probability that a randomly selected person has hearing problems is this. Probability that a person has vision problems is this. Can we compute the probability of a person who has hearing problems or vision problems by adding these? So remember, the main OR formula has probability of the individual minus this and that. So there could be people who have both hearing and vision problems. So we need to subtract those from the hearing and the vision. And since we are not given how many have both the problems, so we do not have enough information to find the probability of hearing or vision. So no, and the reason is that hearing and vision problems are not mutually exclusive, right? Some people may have both problems. Those people would be included twice if we were to just add these probabilities. And in order to not include twice, that's why we subtract the common, but we're not given the common, so that's the answer. Okay, determine the probability that a randomly selected multiple birth for women 15 to 54 involved. So 15 to 54 is all the women. Involved a mother who was 30 to 39 years old. So 30 to 39 would be 30 to 34 and the 35 to 39. So both these will be added up to get the 30 to 39. So you do 2832 plus 1855. 2832 plus 1855, and that needs to be divided by the total. So you add all these up. Now the total can also be done on StatCrunch. So let's try that. Open in StatCrunch. So you do stat, summary stat, column. Number of multiple births is this column. So make sure you're adding the right column, which is the number of multiple births. So sum is not selected by default. So you select it yourself. And it comes out to be 7416. So now I go back. So divided by 7416, and all that gives us a 2832 plus 1855 divided by 7416. So that's 0.632. Determine the probability that randomly, involved a mother who was not 30 to 39. So remember, we already have 30 to 39. So not 30 to 39 can be either found by adding up all those who are not 30 to 39, but we have faster way, because not 30 to 39 is the complement of 30 to 39. And you know that a probability of something and its complement add up to 1. So the not 30 to 39 would simply be 1 minus the 0.632. And that would be 0.368. Who is less than 45? So less than 45 is everybody except this one. So again, the faster way to do that is instead of counting all those who are less than 45, we know that this is the only one that's not less than 45. So the total was, let's see what the total was, 7416. So if we do 7416 minus this 3 minus this last entry, so 7416 minus the last entry, so that gives you how many were less than 45, and then you divide this by 7416. So 7416 minus 120 and divide by 7416, 0.939. Let's see. 7 who are less than 45. So 7416 minus 120 divided by 741. Oh, it's not 939.984. 0.984. So do what I said, but I read it wrong from the calculator. 984. Okay. At least 40. So at least 40 would be 40 to 44 or 45 to 54. So you add up these two. So 372 plus 120. And then you divide that by, again, 7416. 0.066. So if 1,000 multiple births for men were selected, how many would involve at least 40 years old? So at least 40 is this last probability. So you multiply this by 1,000, you get 66. And you know that it's always about and not exact. So about 66. At least 40, is this unusual? So unusual, remember, anything less than 5% probability is unusual. So this probability, if you multiply by 100, is 6.6%. So no, 6.6% is not less than 5%. So it's not unusual. So no, because it was greater than 5%. 100 people were asked, do you favor stronger laws on gun control? 33 that answered yes, 14 were male. Of the 67 that answered no, 6 were male. If one person is selected, what's the probability the person answered yes or was male? So 33 answered yes, and of these 14 were male, and of the 67 that answered no, 6 were male. So the total male is 14 here and 6 here. So 20 males, and but 14 of them were already included here. So in this 33 who answered yes, 14 of the males were already included. So there are 6 more males besides these 33. So 33 males, 33 are yes, and they have some males. And then the only other males are the 6 who answered no. So 33 plus 6 would be 39, and the total people are 100, because 33 answered yes and 67 answered no. So you add 33 to 67, the total is 100. So 100 people total, and yes or male was this 33 plus the additional 6 males. So 39 out of 100 is 0.39.